Next, we'll look at a conduction problem. We have a 2 square meter thermopane window constructed using 2 layers of glass that are 4 millimeters thick and separated by an airspace of 5 millimeters. If the temperature difference is 20 degrees Celsius from inside the house to the outside air, what is the rate of heat flow through the window? And we are given additionally the thermal conductivity for glass and for air. Now for this example problem, we're going to assume that the only insulating materials are the 2 glass pieces themselves and the air in between. We won't be looking at any still air on either side of the glass. So if we do that, we can write down an expression which tells us the rate of heat flow. And we saw that the rate of heat flow previously is equal to the amount of heat per time that flows through a set of materials, and that's going to be equal to the area that the heat has to flow through times the temperature difference, T hot minus T cold, and then divided by the sum of all of the materials, their widths or their thicknesses, divided by each one's thermal conductivity. Okay, so let's just write down what that would be. So first of all, we have the area. The area of the window that the heat has to flow through is 2 square meters. And then the temperature difference is 20 degrees Celsius. And I can use Celsius because I am talking about a temperature difference and not a single temperature. And then I divide by the sum over all of the materials. So first off, I have this 4 millimeter thick piece of glass that the heat has to pass through. And so that would be equivalent to 0.004 meters. And then I need to divide that by the thermal conductivity. And the thermal conductivity is 0.84, so it's 0.84 joules per seconds, meters, degrees Celsius. So that's the first material that the heat has to pass through. Then the heat has to pass through a layer of air between the two glass panes. And that layer of air is 5 millimeters thick, so that would be 0.005 meters, and I would divide that by the thermal conductivity of the air gap, which is 0.0234 joules per second meters degrees Celsius. And then I would have to add on another identical layer of glass. Now, since that second layer of glass is exactly the same as this first layer of glass, I effectively have 2 layers of glass, or twice the thickness of glass as is in this term. So I could just multiply this term by 2. So then if I put that into my calculator, I get a number equal to 179 watts. So 179 watts, or 179 joules every second, is passing through the window.